Why is this not capturing anything? Full screen Elgato. Why is the screen not showing up? What is my check? I'll have to make a checklist, obviously. Okay. I have local OBS running. Oh, I bet I didn't tell it to save projections. Yep, I didn't tell it to save projections. Where is that? Settings, general, projectors, save projectors on exit. Okay. Yes, this will be on YouTube. Right, I should have done all this before. Well, I couldn't do some of it. Twitch, nothings, pop up. So until I figure out what to do for a plugin, I'm going to continue to just drop the chat in here. Now is the camera in widescreen mode? Good. Okay, yeah. I still won't be able to see the camera well until I fix that. I got a new monitor coming that'll hopefully help with that. Yeah, that's good enough. It doesn't matter that they overlap a little. And then I had my info box. Which was, oh, yeah, it's right there. Stream info. It's good to be back. So thank you. I never actually set up chat overlay. I still have that one in there. I'm gonna make a FAQ for people who don't know who I am, because people might get recommended stuff. I could put it on Twitch, but probably people get recommended on YouTube more. So I might just want to make it like on this FAQ. That chat is way too tiny. Yeah, so I guess I just can't do both of these this big. I guess I could shrink one, or shrink the fonts of one. So I just announced this on, oh, I'm sorry, I'm going to be scratching. Just announced this on blue sky, which is just that I want to do a relatively short stream and I probably won't program at all. Just following up on the last stream and demoing a couple other things for various reasons. But you can see on screen that I've written up a list of all the technologies that I need to do for this game that I hopefully will be working on in the streams. So you can see there's a lot to do. Some of that may be fast, some of that may be a day, some of that may be a week, some of that may be a month, some of that may be 3 months. Certainly the ones at the bottom where I don't have any detail. You know, like physics will be interesting because, like I said, I want this to be able to run multiplayer, you know, 500 players on a 500 players plus. If it's like DayZ, then there's, you know, a couple zombies for every player. So want to be able to run that efficiently. So we'll see how that goes. There may be other technology I didn't think of here. Obviously, 90% of the technology listed is rendering. I didn't even put game on there because I don't think of that as technology. Yeah, should I announce this on IFMod? I wonder. I guess I could put it on Nothings, the Nothings channel. BB post. Post equal BB post Nothings equals streaming program. IFMud is a multi-user dungeon, quote unquote. One that is dedicated to if. Yeah, no worries. It's worth explaining anyway. If I'm going to talk about it on stream, I could have just done it without saying anything. So, let's check if anybody's like saying I got the thing wrong. So I did not pre-announce this, so people will just have to catch up as they show up. I can hide this, disable the preview. How do I disable preview? Lock preview? I forget. Somebody told me how to do this yesterday or Monday, and I've already forgotten. Profile, is it under settings? That would be really annoying if you have to go under settings every time to disable it. General, output. No, I don't see it there. Oh, preview. Hide overflow. No, it's not there. Try the tech stack. Are you most excited about what you... So the fact that I'm already doing a Wednesday stream right after doing a Monday stream does not mean I'm already on a Monday, Wednesday, Friday schedule. It's just I'm not going to be programming today. This is just a follow-up of the last stream. I mean, who knows? On Friday I might feel like streaming, but I'm saying there's no plan. Open the stream and check what it looks like. How do I already have 65 viewers? That's crazy. Is the last stream available somewhere? Yes, it's on YouTube. The Programming FAQ has a link to my YouTube channel. So the FAQ is on the panel on Twitch under the video. Thank you for adding the link there. Typeface makes me weep, but y'all do what brings you joy. Yeah, I am 58 years old, so my eyesight is, gradually declining. So it's a fixed width font, of course. It's Consolus, which is a font that Microsoft created for programmers. It's better than Courier New. And Consolus, I feel like the weight of the font is a little light, so I use bold, which is a little heavy, but I'd rather it be heavy than bold because of my eyesight. It makes it possible for me to actually read it. So what are we going to do? What order do I want to do this in? I don't want to wait for people to show up because then we're just sitting here doing nothing and it makes the YouTube stream, the YouTube archive dumb and stuff, but I don't want to have to repeat myself too much. Yeah, so let's start with just a random demo. ZMC. Here's the ZMC. Let's see if this still runs. From 2012. That's after I started at RAD. I wonder when I first started working on it. You have to view everything. It's probably all 2012. All right, so let's see if we can build it, or do we even need to build it? Maybe we can just run it. Yeah, we can just run it. Okay. I can't resize it, so you're going to see a slightly cropped view here. So this is a little voxel engine that I made. This predates STB voxel render. I can't see chat anymore. Oh, I can put it on the screen. My mouse. Do I have a way to uncapture the mouse? Oh, it doesn't use STB platform because it's old. Set cursor pause. Real NDT. No, that's gonna all be true. Yeah, I mean, I never needed to because I was never demoing for people before. But anyway, so is there a flight? Is there a flight mode? There has to be a flight mode. I don't see a flight mode. There's got to be a flight mode. Here we go. Cheat, maybe? F. Shift F? What was F? Control F. Yeah, okay, there we go. So, right, I didn't put any time into the actual contents of the buildings, right? The buildings are just these empty things. But they're all constructed out of voxels, textured voxels, textured blocks. And the engine is fully voxelized everywhere. Do I still have there was a crazy thing that I put in somewhere, but it might not be in this version. I might need to turn on an ifdef to show it. So this is just one of my early block experiments. Oh, right, I wanted to, I've just got to stop it and move this chat so I can see the chat. The little characters are just me testing the Ken Perlin published a thing on how to do two-joint IK in a closed form solution, which is just really nice. So I did a little experiment with these guys walking and running around. And you can see there's a little physics, right? They run into stuff. There's no AI. They just pick a random direction and run. But anyway, so the main thing is we're not drawing a very far distance. So let me go into, and the frame rate is huge. So let's see if we can bump all that stuff up. I've not looked at this code in like 15 years, so you know, a little patience, please. But so that's going to be an R world, R, is there a top level R main? No, it's going to be an R world. Is there a distance? Yes, near distance, view farthest, view far. So I guess I want view farthest. And that's probably going to go in the header file. Maybe not. View farthest. Let's see if it exists and I can just uncomment it. How do you do this? Find in files. View farthest. No, that didn't work because it didn't find the one we're looking at. The directory must be set wrong. Find in files, view farthest, CMC. Okay. M data. Okay. Oh, I should fix the, I could just fix the screen size too. Oh, it's really slow because it has to build out that far because this wasn't. And there is fog to hide it. Okay. Right. So that looks a lot better. I used to run around on this go, oh, you could make a game where you just parkour on top of things. Okay, can I change the screen size? I was in the main. Where was the main? Client main. What do we want to be? We want to be about the size of this window. So it's 2000 by 1440. Let's do that. Except I can't read. Oh, I didn't use it. Oh, because I didn't comment out the other one. So main loop. What we want to do is, like, while the key is down, we don't want to teleport the cursor. All right, so where's the cursor teleport happen? Here. And how can I tell that key is up or down? So case, this is just, we'll use the same hack that we did in the other ones. Cursor hack. Oh, no, what we want is on event. So yeah, we want here. Case Z minus 60, Z minus 64. Cursor hack. Span cursor hack. So I said I wasn't going to do any programming. This is the only program I'm going to do. Well, this will be the last one. I'm positive. All right. Also, it did build. All right. So. Dun, 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 dun. And it doesn't work. Oh, I don't unhide the cursor is the problem. How do you hide the cursor? Show cursor? Yeah. Where's my control Z? And then if it's cursor hack is 0, we want to hide it. So we just press the cursor. All right, maybe this will work. God dang. Yes, okay. And then let's bring this back over. All right. Now, can I get my mouse stable again? No, I can't. It won't let me look at an intermediate. Oh, there. Oh, I have to Control Z. That's why. Okay. Control F to fly. Park the cursor in the air, and I'll be right back. Okay, so like I said, this was like 13 years ago. And the main thing about it is that it's an infinite procedural city. You could jump, you could teleport anywhere on the map. And oh, I just did it in a little experimental pile of things. That's not actually supposed to be part of the real content, just me testing stuff. And you can see I'm on this one road that goes a very long way, but eventually it'll deflect. Yeah, there. We're going to run into a building. So it was a big challenge. Like, how do I make a world like this where you can teleport anywhere and it's procedural and it's all connected? And that was an interesting and fun challenge that I thought I would talk about a little bit, what I did for this, because I think it's an interesting problem and solution. But you could see how you could parkour. Of course, oh, I hit Control F, not Control Z. Of course, Mirror's Edge came out like 4 years before this, so it's not like this was... The idea of jumping around on the roof of a building was original. But the idea that it could be a procedural city... Anyway, but that wasn't the original plan. That was just, I wanted a procedural city. It's actually meant to be a zombie fighting game. It's a little inspired by DayZ, but the intention was not to do DayZ player versus player stuff. It was meant to be just a player versus enemy game with zombies. But, you know, even back before I started at Looking Glass, so 93, I did not ever work at Valve. Back in 93, I was thinking about making a whole procedural city or a big city that like every room existed. Of course, there's no point in that. Like if anything, having every room exist creates like busy work. That detective voxel game Shadows, whatever it is, actually is a good version of that, because every room exists, but you have no reason to go in them until you have a mission that sends you there. But it is there, so like if you're running away from something bad happening, then you can you do it. So this, I believe, is a place where the procedural city made a block that was too small, and it doesn't know how to make a building to fit that. Is probably what this is. Again, this is 15 years ago, so I'm not positive. But I want to talk about what the algorithm is because I think it's interesting. So how do you make a big procedural city where it's all interconnected, there's no dead ends, all the roads all connect, but you have random access? You can just go anywhere in the city and generate that. I mean, you know, yes, shadow of doubt. Of course, you know, it's not infinite. You'll run out of... It's 32-bit, so, you know, it is voxel-based 32-bits, so it might actually go out to 32 bits. I don't remember. And you could see that the ground is slightly sloped. There were places where the ground sloped. So, you know, that's probably just Perlin noise or something like I think it's not actually per noise. I think I made a special fast noise because the building the blocks is so slow or whatever. But I will point out that the startup took a while. But if I just fly in one direction, the flying is, this is a debug mode. You're never supposed to move this fast. And if I fly, you don't see any pop in. I mean, of course, the view distance isn't that huge, but the view distance is, I guess you could be in a building and look out the building. So yeah, maybe there the view distance is noticeable, but if you were on the ground, the view distance would never be that noticeable. But you'd also be moving slower, so I could push it out further. What is our 800 megabytes? So this is like before I start compacting my voxels to be smart. And obviously I have a near clipping plane here that's set too close, or yeah, it's set too far away. But 800 megabytes is a lot running on the old machines that I had in 2012. But obviously this is still a 980 Ti, which is again an old machine, but it was the highest end GPU at the time. Easy art content creating for coders, absolutely. And like it's easy for the coders and it's tolerable for the audience. Like you could get away with it. At least Minecraft code. I don't know if you still can. Like really plain blocks like this. But again, like the intent would be that there'd be a lot more detail to it just at a block level than what exists right now. This is just done really quickly. Okay, so let's talk about how do I make this infinite seamless world. as I believe that was what it was called in the SDB voxel render trailer. And the way we're going to do that is I should make a new scene. And I should add the webcam to it. And I should full size that. And then I should hit this button. Oh, it tilted at the end there. And then the only problem is the microphone. I guess I could hold it like a crazy young person. Yeah, exactly. A whiteboard time. And I didn't plan that. This is just my standing position for the desk, and it happens to exactly match. I had never tested that. That's why we do test streams. And yell at me if I'm not audible. I really want this light on the other side because I'm gonna want to stand here, and that puts me in the light. So I don't have a good place to put it though. I don't really. I guess I have to buy a new light I can fit in there. I have some of those little portable ones. Just don't know where. Maybe with my camera gear. I don't want to spend the time on it right now. What can I do? I have a desk lamp. Where can I put the desk lamp? I guess I could put it here. Is anybody yelling at me about audio? Very audible. We can even hear them wiping the board. Oh, so maybe I can just leave it. Let me make it face. How do I make it face the... Why is this not getting Slack? Okay, it's just... There we go. Tilt that up. It is like a high quality audio music instrument mic. Or Oh. Yes, I see what's going on. Let me try rebooting the camera capture. Or maybe it's the camera. It might be that the camera itself. That weird pattern was my blinds. I thought it was something glitched. And then we need to... I think you're getting webcam audio. No, it was just because I was away from the thing. It's definitely coming through. Oh, man. Is it coming through? Oh, shit, that is webcam mic. Why? Because I didn't add the source. Because I made a new source. A new profile. Or new scene. That's the word. Thank you for catching that. Existing. So you guys were happy with the webcam audio. Let's see what it's like with the real audio. Except it's... Except it's not showing that on my... Did that get disconnected? Oh, this is why we do test streams. Why is this not showing up in the audio mixer? It's so dumb because the source is named Mic Aux. And then my webcam source is called webcam. And in the audio mixer, it shows a thing called Mic Aux. So I thought that that was actually my Mic Aux. But that's actually my webcam. You jerks. All right, let's remove that. Let's add it again. Unless that's just misnamed or something. Audio input capture. Let's create a new one. There it is. Okay, I've disabled the webcam audio. I guess it's going to be single channel. Let me figure out how to route it both channels. Yeah, it's mono, but it's showing as only being left. Yeah. How in OBS do I tell it to route that to both channels? They must have support for that, right? Advanced audio properties. Mono. Testing. Okay. So now with the real mic, do I sound okay? I can turn it up. Turn it up. Testing, here I am. I'm about to start talking about what's on the screen. I'll fix the screen display. It's over bright because I added the light. I'll fix that. Programs, Logitech, camera settings. A little lower, it's clipping. Yeah, I mean, the problem is I'm moving further and closer to the microphone, depending on where I am. So it can't be perfect, right? It's going to be... It's advanced. Wait, why is it showing me a black screen? Oh, because it won't read it while it's OBS is reading it. Okay, so can I open it in OBS? Webcam properties. Yeah, okay. No, except it doesn't let me set the settings here. How do I open my webcam settings while I'm in OBS? This works in like Zoom, or what do we call it? Is it Zoom? What's the name of this? I haven't done any of this in so long. Yeah, Zoom. Yeah, it's pretty good right now, but that's because I'm going to be standing a little further back in a second. Well, I'll just stop the camera just for a second while I get the properties, since it wouldn't let me open them. Or it opened them, but it showed me a black screen. It was very weird. Oh, no, it's still showing me a black screen. All right, let me turn it back on. Can I control it? Maybe this will just work. Brightness, come way down. Thank you. Contrast. This is not looking any better with the light than the old way, I don't think. This is why we do test streams. Okay, so how does this work? Okay, the world is divided up into chunks. I think they're 128 by 128 or 256 by 256. And so then we build a vertex buffer. Each vertex buffer is one of those chunks, right? And so you build the world in chunks. So what is the reflection that, oh, that's this. I could just turn that one off for now. Okay. So we have a grid chunk, then we have another grid chunk, and we have another grid chunk. And we can build each of these independently of all the others. But each one is, like I said, 128 by 128 or 256 by 256. Is this visible? Is this clear enough? Do I need to bring the camera in closer? Like, are the lines thick enough to be seen? Okay. So I came up with a strategy, and I didn't think of it this way, but in hindsight, this is a good way to think about it. So there's a thing you can do for procedural generation where you have a bunch of pre-designed tiles, and only some tiles fit against each other. They're called wing tiles. So you make a tile and you color the edges. And so this one has green and green and red and blue. And it has some set of content in here. And the pink defines what the content should look like so that it will match up on the other side. And blue defines a different thing for what the content should look like. And it's a little misleading to call both of these green because the horizontals and the verticals are totally independent. Well, unless you allow your tiles to rotate, which you could. So, then the way you do this, to do procedural access, is you have some way of randomly determining anywhere on the map what color this edge should be. And then you pseudo-randomly, and this edge, and this edge, and this edge. And you pseudo-randomly pick some tile that fits that pattern. Maybe there's only one tile that fits that pattern. There has to be at least one. And the only thing about that is that you did this with texture data, you get all this really nice, perfect texture data, except this corner is a little weird what happens there because it's the meeting of 4 different colors that don't know about each other. So an improvement to weighing tiles that someone came up with is that you, instead of coloring the edges, you color the corners. Right, and so you say, this corner is blue, this corner is green, this corner is green, and this corner is pink. And then you effectively have, you can basically say for each pair, you define now a new unique color, even more unique color, and that's the edge color. And then you can still define everything with edges, but you also can just do it directly with the corner colors. So you say, you know, this edge is a green to pink edge, this edge is a green to pink edge, this edge is a green to blue edge, this edge is a green to blue edge. And now you compute, now what you do when you set this up is you say, well, this is what the content should look like around this point. And for a blue. And then all of the blues, when they get generated, will generate content that matches up. And you say, you know, here's what it should look like around the green. And you say, and here's what it should look like along the blue-green edge. So that's wing corner tiles. So there's, oh, covers a bit of the right edge of the board. Yeah. I probably could have just not drawn there, but all right. So if you do this, now you just have to compute colors at every vertex, which is actually a little easier than the edges, and do that same logic of pick a tile that fits. Okay, that's a high concept, but there's no pre-computed tiles in this thing at all. Like I said, this is not how I originally conceived of it, but in hindsight, this is how I kind of figured out what I was doing effectively. So I want to generate this 128 by 128 tile, but it needs to match up to the adjacent tiles. So what I do is I define procedurally, I look at this edge and I say, here's what the content of this edge is going to be independent of any tiles. I just pseudo-randomly pick this spot and I say, okay, I'm going to have a road cross here and a road cross here, and I'm going to put, how does this work? Oh, so basically it makes a rectangular block. So blocks don't have to be rectangular, but the easiest thing for a block to be is rectangular. So the corner doesn't know, so the corner decides, like, the block is going to be 2 buildings deep and however many buildings wide. It's going to have buildings like this. Because it wants to make sure the buildings match up on either side, so it actually has to say, this edge contains these buildings and these roads. And of course you can't really see what it was anymore because I didn't color code it. But it basically, and you could kind of try to be smart. Well, it contains this vertical slice, 1 voxel wide, of these buildings, and not say exactly what they are beyond that. But it's a lot simpler when I did it to just say, it's got a building here, a building here, a building here, this particular building, and it knows what the block shape is. It doesn't know, what it does is it says, okay, if I'm going to make, you know, like I said, it's going to make buildings in a 2 deep this way. This is super complicated, right? Like, this was why this was a challenge, trying to figure out how to make this all work. So this is the, right, and then the roads are this. So it says, I'm going to say that this edge crosses through a block that looks like this. The edge is going to be like here. And so what it actually computes, what it determines must be on the edge is this. And buildings have like a front door, not that it's visible in this thing, but right. And so the front door on these buildings, the side that faces a road, are these, and it's computed that in advance. It doesn't know exactly how it's going to extend on the other side, and it picks randomly which way to do this. Now, if we look, roads are like 1, 2, 3, 4, 5, 6, 6 voxels wide, 8 voxels wide. Because it's maybe a meter scale. I'm not sure. I don't remember. Right? Long time ago. What's debug viz? This looks so dark to me. Did it look better the other way? Come on, you can grab it. No, that's so shadowy because the lighting's too direct. It's just I pick up so much monitor glow without a bright light. So I need a soft light, not a direct light. Like, what kind of debug visualization do you want to see? Oh, this stuff? No, I don't have any debug visualization for this particular part of the problem. So conceptually, what happens is, right, we're building one tile. I'm going to make it bigger now. We're building one tile. And what we say is we have major roads and minor roads. And we have every edge has 2 major roads enter. Right, so we're computing this independently. Every edge. So what is from generating the edges of chunks and deterministically. Yes. So, I mean, deterministically is pseudo-randomly still, right? So it's pseudo-randomly picking edges and then filling in data to meet it, also pseudo-randomly, with multiple possible strategies, although I've only implemented one, I think. So, what I wanted was, I wanted the possibility that a major road would go straight through without changing for a long distance. So there's a superstructure to the edge generator that, like, you know, has a macro structure that allows it to make sure it picks the same edge, the same position on the edge sometimes for some roads. This would also allow you to, like, name the roads. You could have that superstructure pick a name for that road that would show up on signage consistently, say, if you had that. So each edge looks like this. It's like, I'm going to put some minor roads in and create these block structures that we were talking about that, sorry, that's wrong. That it only knows, it knows the near edge on every single one, which might be that, say. I don't remember how I dealt with the corners. The whole point of the wing corners was I realized after the fact that the strategy I should have done was to approach it like you would wing corners, which I'll talk about in a moment. But anyway, so it has that data for each of them, and yeah, now it's going to meet these constraints. And I spent so much time. So the whole problem is something called road networks. That's what when you just start with making the roads, and then you're going to fill the buildings in afterwards. So we're trying to make a procedural random access road network that's only on 90-degree angles. Sounds really easy, and it would be really easy if you didn't start introducing these constraints I have, like wanting these long infinite roads. So the problem is, how do you connect these roads? They need to all eventually connect to each other. You could do something like this, and they do all eventually connect to each other, but it's not very city-like that there's no direct connection. So you could do that, but that's kind of just like the naivest, oh, I'm just going to make sure they're all connected in a dumb way, right? Like, it's not very city-like in how it's structured. What you kind of want to do is you want to go, well, if they're in line, they can cut straight through. If they're not in line, they need to change. But maybe they should change where one of these is. So we should do that. And this one wants to connect to this. So, we could do it the far one, and we could do that, and we could connect that, or something like that. And so, I was trying to do something like that, but I kept having cases where, they like kind of miss, because what you want each intersection to be a distinct thing. You don't want two roads to happen to come together, like this intersection is too close to that intersection. I mean, you do have that happen in the real world, and then a human sits there and figures out what's the weird intersection design for it. And I didn't want to deal with that. I wanted to make sure the intersections were always had like at least one voxel separation. um, and so I spent so long on trying to figure out how to make this work and look good. And the solution I ended up coming up with was doing this. That I just said is terrible. Then if this edge, this is a major road that could connect straight through. So then you say, is this edge far enough away? Okay, then it's allowed to do it. But if it's too close to put any buildings in here, like maybe you could only have one row instead of two. Like normally everything is two rows of buildings deep, but maybe you could only have one row of buildings. I don't remember how to put that. This one needs to zigzag. So it says, well, let me try a arbitrary zigzag. And as if this turns out to come too close to that, then we'll just not put in that zigzag because we know they are connected by the indirect box connection. So I believe in every single chunk there is one of these boxes. You can't tell going through the city. Like, it's not obvious. But there is, I don't know, maybe there's not wonkiness at the corners anymore. But what I eventually concluded what I should do is start by saying at every vertex there is some building, and we'll define what that building is. Then we need to say what the block is around it. And let's just always make it like a 2x2 set of buildings, just as a simplification. It'll always be 2x2 centered on one of the buildings. And that forces you to have some minor roads here. Does mean there will be a sort of a pattern, although it can shift around to which building it lines up with. So there might sort of be a regular pattern. And I might have ended up doing something similar. I don't remember what I ended up doing about this. But this was so complicated. I got it working. It looks okay. I'm pretty happy with it. And then I didn't work on that project anymore. Testing. 1, 2, 3. This is the webcam mic again. So yesterday's stream was probably all on the webcam mic because I didn't configure the audio correctly. That's funny. I did the whole test. There we go. It should be back to just this mic now. Yeah, I'm surprised that I didn't even, like, I listened to a bunch of the stream. I assume that already got fixed. That you're, like, I had to have both on just for a moment while I was switching. Clipping now. Okay, yeah, because now I'm sitting close. And it's actually showing clipping on my device, so I should be able to. All right. How's that? Too quiet now. Testing 1, 2, 3. Bit quiet. Well, I mean, if I turn it up more, it's going to start clipping again. So I guess the question is, why is it clipping? Oh, is somebody's volume set? No? Okay, it doesn't show as... it's just barely clipping. Testing 1, 2, 3. I don't know. I don't want... that's still clipping. I don't want to go any louder than that. It's going to clip. Oh no, this meter doesn't actually clip. The red is not actually clipping. Ugh, I hate that. Now it's going to change as I move around because of the mic position. So do let me know. But not when I'm weirdly leaning over. All right. I'm super pink. Okay, now back to figuring out why my capture device isn't... All right, I'm going to just close OBS and restart it. Not the one you guys are seeing. My secret one. Yep, okay. Oh, sorry about all that. Control Z. Okay, so yeah, so this is just, I wanted to just show this old project. I spent so much time trying to figure out how to make that work. Did make it work, then never did anything with it. Whoops, I gotta find a better place for the mic. Why is it swinging? Okay. It's probably quiet again. How's the position? That's okay. All right, so yeah, let me see if the tile, weighing tiles, was it probably? Where would that be? Map build, something like that. Map gen tile, probably. Weighing tiles. Why is that? Okay. Frustum culling is all, well, it's chunk. It's just frustum culling the whole chunk on the CPU and drawing everything otherwise. So test weighing tiles. I guess let's just try and commenting it and see what happens. So basically, this was just a test of could you make a building using weighing tiles, the interior of a building, and it was an interesting experiment, not something I think I would ship. Come on, get up. Okay, there we go. Okay, yeah, here we go. So it was just kind of an interesting thing to like try to make something where you can see where the tiles are, I hope. But you know, if if this was a building you were in, like, it looks pretty pretty erratic, even though it's got that regular grid to it, actually. But, you know, just a little test. And obviously, I took off the roof, so and it's just plopped down on the map randomly. Just wanted to see what it would do. And I think this is wing tiles with colored edges to match things up. So again, it's procedural. So you could make, you know, a thing that's like, you know, a 2-mile wide long building with random access to it using this, which is just kind of amusing. I notice all the VARs are all at the top of the function. Just have it or just want to support old C compilers. I'm in VC6. So VC6 doesn't support declare anywhere. C99 didn't become standard in MSVC until 2017, but this compiler actually predates C99. This is a 1998 compiler. It's all in the FAQ. Anyway, so that was just a random thing I wanted to demo. I follow somebody who's making a city, procedural city, and I wanted to show you all it, and now I can send them when I archive it on YouTube, I can send them a link. And then this is a project that I talked about. I don't know what the state of it is. Okay, yeah, it's the... So, where's the Earth? Have I disabled the Earth? I've disabled the Earth. Scene, maybe? No. Render. Planet. It didn't open a message box, so it is still loading them, so it must just be disabled from rendering them. I was writing up an article on this, and I intentionally turned the planet black as a reference for doing maybe it's in the shader. It might be in the shader. Planet. Aha. Okay, yeah. So this is just a demo. This is I spent a bunch of time on the atmosphere rendering from space to get the thing. This is, if you get too low, it turns pink because I didn't handle a case intentionally. You know, and it's subtle there, but it does actually do the right thing. Like if you are low enough and you get a sunrise, right? The sunrise is like that. And then the other thing that I posted about, should be near it. Where is it? There's a big plane somewhere. Maybe it's if zeroed out. Oh, yeah. It doesn't matter, but yes. Thanks for the notifying me. Dunk, 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 dunk. Where would that be? I haven't looked at this code in a month. All right, let's find the shader for it. Where do we load our shaders? Here's where we load our shaders. It is
None of those. None of those shaders are the one for the thing I'm looking for. Hexagon Atlas. That'll work. There we go. So this is another thing that I mentioned that I worked on. How do I move slowly in this? No, that's even faster. Dang. Where's movement? RenderDoc doesn't work with, well, probably modern versions of RenderDoc don't work with Win7, and it doesn't support immediate mode, which I use for most stuff. Render scene. Oh, it's in a different file. Okay, yeah, here's movement. Move speed. Hold down control to move slowly. Where did it go? Okay. That's too slow. There we go. So what this is, no, it's not fixed function GL. It's all shaders. It's just using immediate mode to send the geometry, but the shaders are there. So there's a little bit of aliasing which you might be able to see or might not. So this was a thing I made. We talked in the last stream about the anti-tiling technique of drawing multiple splats and having them blend together to create, when you have disorganized textures, you can just kind of randomly blend them together in splats and it looks fine. This, on the other hand, is for doing coherent stuff, although it happens to be hexagons like the other thing was hexagons. But this is actually tile mapped, so it's like a console or arcade game where you have character, you have little sprites that are 8x8 or 16x16. Here they're probably like 64x64 or 128x128. And this happens to have a square grid that the contents of the square grid have been designed so that you can create a hexagonal image out of it. And that just happens to be the only test image I have. But this could be like, could just be a big fixed with character display, right? Like, but the interesting thing about that is like when you, it's basically virtual texture mapping as well. But in virtual texture mapping, the common technique is that you pad your tiles at the edges so that you can bilerp around the edges. And this is actually bilerping by sampling for all four samples itself. It's doing the bilinear interpolation itself by sampling all four, because the four taps might fall in different tiles. They usually don't, and so there's a fast path that when they don't, and so it's still pretty fast. You know, and all of this is running. This is an MSAA display, HDR. That's how we get the nice bloom on the sun, right? Right, the actual sun size, as we saw during the right, the sun is actually tiny, as we saw with the sunrise. I can't get it to show. Oh, well, it doesn't recolor, so it's hard to tell. Right, which is why it glares in front of the thing, because that's all glare. The sun is just a little tiny thing at the center. But anyway, so this is a debug build, right? That's why it's immediate mode, is because I'm not pushing that much geometry. Like all the complexity here is inside the shader. Even this is a vertex buffer. The planet has more triangles, but that's just so that it looks nice and round, right? Like I wanted to actually, and might be for a sci-fi game, maybe you play it actually has bumpiness that's visible. This is actually bump mapped the way that real Earth is, but it's just too small to see, and then I can't get low enough without that debug thing showing up. Oh, there it is. The eternal find the thing in space. Fortunately, this thing is huge. Anyway, so yeah, I did this tile map thing because I wanted to make non-tiling textures on really big ships. So I wanted some technology that would let me make a really big ship without a simple repetition. So you could make structured stuff. It has to be grid aligned because it's using tiles. And that was just something I had shown on Blue Sky, so I wanted to demo it here too. What else do I want to talk about from last stream? If anyone has any questions, let's start them now, because I'm nearly ready to wrap up, because I just wanted to demo this stuff. So one thing we looked at last time was the compute shader voxel renderer, and I had a weird thing where I was like, oh, well, this version that we were looking at actually seems to have some debugging evidence that points to a problem, but that turned out to be false. There are two reasons it turned out to be false. One is that I still have to run OBS. It's not doing the actual capturing, but it's sending the data to the capture card, and that's actually taking 7 milliseconds slowing my game down by 7 milliseconds per frame on the compute shader voxel. It's not slowing this down very much, it doesn't look like, because obviously I'm running at 3 milliseconds per frame, so it's not adding 7 milliseconds per frame. But that's this. How does this one work? F. But so if I do come down to here, and we see 1.6 milliseconds downward, 5.6 milliseconds upward, it adds up to about 7 milliseconds, and the frame time is 14 milliseconds. That's because if I turned off my OBS, it would drop down to 7. I can't do it because then you won't see the stream anymore. And so you won't see that it came down. So there is no actual mismatch here. And then the other thing was actually, even then there was still a mismatch, but that was because my GPU profiling was wrong. Because the GPU profiling is through a double buffered kind of thing to read back the data. And I was triple buffering to have enough delay before I tried to read back the times, and it turned out that even triple buffering wasn't enough. I went to 5 level buffering, so I'm accessing the times from 5 frames before, and that worked. And then I rewrote that system to actually not have to have a fixed, like you can keep waiting until it's actually ready, and I just hadn't put logic into keep waiting until it's actually ready. 980 is a pretty old GPU, but it is top of the line from that time, and so it's maybe representative of what a modern slower machine or laptop might be like. I don't actually know, I haven't tested, but that's why I've kept it in here, and I want to keep developing with it. All of that, the space stuff that we just looked at, I'm optimizing on this thing. Oh yeah, I started to talk about that. So like this is HDR, and it's MSAA. This is all going to be it's going to be. If I ever do work on this, it's forward rendered. Like all my stuff is always forward rendered. So I can take advantage of MSAA because it's forward rendered. And it's MSAA HDR, which is a lot of memory potentially. But it's actually only a 32-bit frame buffer. It's the 10-10-10-2 format. So it's not very HDR, but it's enough. I use a nonlinear encoding that allows me to put the sun in super bright, and then I do the old classical thing of downsampling and upsampling that to get the nice glare from the early 2000s look. Let's get that to see the actual size of the sun. There it is. Anyway, aiming at 1050. My laptop 4050 I found to be pretty close to 90. People on stream still use 1050, 1050 Ti, 1060. Oh, really? That's probably slower than a 980 Ti. So like a 1080 Ti is maybe like 1.5x a 980 Ti. I don't know. Interesting. Let me scroll back and see if I missed anything. The chat window, fixed function. So yeah, did I satisfactorily explain why the immediate mode doesn't matter? I started to explain it, but I'm not sure I finished. What else did I want to go back over? Okay, so yeah, so I'm not going to, so we're taking that out of this list. We are not going to investigate Voxcall because, yeah, all those things. Active future projects. So, 32 kilometer by 32 kilometer terrain in 2 gigabytes of GPU VRAM. Low amount of geometry, most of the complexity in the shader is what I got. Yeah, that's largely it. That if there's a lot of geometry, it goes in a vertex buffer. If I care, when I start caring about performance, yeah, that is all correct. And low amount of geometry doesn't have to be that low, right? Like, because the computer can push 40 million triangle. This, the 680 Ti that I had, or 680 whatever it was, that I had for STB voxel render, was doing 40 million triangles, but only at 30 FPS. So that was 20 million triangles at 60 FPS. Was that per second or per frame? That had to be per frame, right? Like I wouldn't, yeah, I'd only be showing per frame stats. So if you can do 20 million triangles with vertex buffers, you ought to be able to do 20,000 triangles with immediate mode, right? Like, it just shouldn't be that bad. When I say vertex buffers, I mean vertex and index buffers. No, I am caring about performance. I'm not caring about the 0.001% performance. Yeah, no, it is true that normally my default strategy is optimized by default, but when I'm researching, so I'm like experimenting and testing, then I use immediate mode and don't worry about performance. But you know, like, does this have, like the text at the top? Actually, that probably all goes through vertex buffers because, oh no, maybe I did. So STB platform, I tried to not use immediate mode in it so that you could use it with core, but I think I might have slipped on that eventually. Yeah, I did. Yep. Okay, there too. But you can see that, you know, like by design, the stuff in platform is not very reliant on it because it doesn't even need to send any real data because it's all being computed inside a shader. But anyway, yeah, and in my experience, immediate mode is the easiest way to screw around. I've never looked at SoCal. Yeah, so rip Voxcall. It's the mystery project that suddenly was 3 times slower than it had been, and I never know why, and we'll never get a game out of it because of that. I mean, we probably would never have gotten a game out of it anyway, but I mean, that the potential for that PUBG Zoom hide in the grass scenario was just so good. It's disappointing. Real challenge is using one shader for everything. What context was it? Think a modern compiler might produce a more optimized cogen than VC6? Yes, it absolutely would be faster, but it would not affect the performance of this, right? Because the GPU and the CPU are running in parallel. And so as long as your GPU limited, it doesn't matter how slow the CPU is. So like I said, this is a debug build. I almost always do all of my work in the debug build because the CPU is never the limiting factor. Now on that Voxel City, the Voxel City was all being as you moved around, it had to build the chunks on the CPU, and their performance did matter. And there, we were probably running in release mode, although I don't know. Maybe that was why it was slow. Oh, that was why it was slow. Oh no, that's the wrong file. No wonder. It's ZMC. But we were in debug mode. It's ZMC as well. Oh, well, it's the Wang tile stuff, so we can just disable that. Where wasn't that in? It was in map build? Map Gentile? Test Wang. Yeah. Here's where I have to exit and restart. Oh, there's a bug. Who knows? Oh, it's in the... Well, see, that's because I always ran into debug mode. Anyway, I'm not going to debug that. It's this ancient project. Back to 40 million. I doubt I would use Jai. Just because it's probably not a significant enough improvement to be worth learning. A lot of your work experiments seem to revolve around procedural stuff and voxels. Has that been an interest for a long time or something that's relatively recent? So I don't know if you know about the sphere tracing algorithm that's used for SDF rendering. So SDF rendering, you assign distance field, you take a sphere, you define a sphere by saying you have a point and you have the distance around the point, a field that describes the distance around the point, and then you pick an isosurface. You say take the distance from the point and subtract 20, and now the isosurface where the field is 0 is a sphere around that point, and then you ray trace through and find the surface of the SDF. It's a common thing in the demo scene world. And the sphere tracing algorithm is that when you sample a point and you're trying to find the surface, and the point it has the value of 17, the distance field has a value of 17, then the nearest that you might be to a surface is 17 units away. Because if you were closer than 17 units away, like that distance field is wrong. So you can now take your next step while you're ray marching. Your next step can be 17 steps. Now that won't necessarily, the direction that you're going is not necessarily the direction where there was a surface 17 units away. So you'll get a distance of 3. You could even get a larger distance. So that's called sphere tracing. And in the 90s, I kept trying to figure out ways to software render voxels. I wanted to software render a whole voxel world. And I tried a whole bunch of different things. And one thing that I did was I invented sphere tracing, although probably it was a reinvention even then. And the idea was I had a 3D grid. I was just trying to draw cubes. I wasn't trying to do a nice distance field, but I was just trying to draw cubes. So I had various versions of this where I'd like pack columns or do various things. But one version was I just had a big open 3D grid, 32 by 32 by 32 or whatever, and ray trace through it. And a thing that I did is that I made a version of that where it was like, if the value, it was just a byte per voxel, and if the value was bigger than 128, then it was a color. Well, 64, it was a color, because palletized colors in those days anyway. And if it was 1, 2, 3, 4, then it meant you could step that distance. So it would take its current step, would read some value in the it was a bound on how far it could step, and if the value in it was 0, that meant you were right next to a surface and it would step by 1/16 or something like that. In the SDS, it's continuous, so it can get arbitrarily close. In mine, it was this bounding distance. And so once you got really close, it just had to arbitrarily step a small size. So that was one of the probably like 8 different voxel renders I graded in the 90s. Now that stuff wasn't procedural, but I've definitely been like pushing on voxels for 30 years or whatever. 40, 35 years. Scrolling back, checking for more comments, questions. But yeah, so the original question was, would a new compiler help? And I did explain the whole debug thing. But just to absolutely clarify, yes, a new compiler would be a good idea if performance matters. Like, if I do this project, I want to have a server and show that you can make a server that doesn't have to be that fast of a server to run a large number of clients. That server isn't going to be doing any graphics. So that server needs to run fast, so that has to be compiled with the modern compiler. Okay, any more questions? Questions about the previous stream, questions because you missed the previous stream, questions about the future streams, questions about this project, questions about any of the projects I've shown, questions about Looking Glass, questions about RAD, questions about Epic that don't violate my NDA. Well, you can ask the question and I won't do it. What are you playing on stream going forward? So I'm going to do this game. Okay. Best case scenario. I explained this last time, but best case scenario, not guaranteed, not certain, not a promise, not even really an intention. Just knowing myself and thinking about where it could go. Best case scenario, I'll stream Monday, Wednesday, Friday. Probably would do something like Monday and Wednesday I would work on an indie game like this. And Friday I would do STB maintenance. Maybe that would then, so that I can finally get through my STB stuff, because maybe I'll be more willing to sit through it if I'm also on stream and chatting with people. And so I picked Friday for that because I'm hoping that Friday would be the day people are more talkative. It is not a New Year's resolution. I had no idea I was going to do this on New Year's. But like I said, I know you're joking, but like I said, not a guarantee, not even a plan. It is a thought that I've had that, like, that is where it could go. The fact that I'm already here streaming on Wednesday is just a little suspicious. But I don't want to make any promises. And then, yeah, and this project, if you weren't around for the previous discussion of it, is this. It is a 32 kilometer by 32 kilometer open world terrain. So it kind of inspired by Arma, things like PUBG. Arma is the engine behind DayZ. And that's a bigger terrain than they have. But it's all done by storing it on the GPU. Only takes up 2 gigabytes, so hopefully should be able to run on older hardware. The entire thing is in 2 gigabytes. As I've said before, it's a solution in search of a problem, because the thing it solves is you can teleport anywhere on the map instantly and there's no streaming because it's all already on the GPU. And that's not I don't have any game design to exploit that. You can imagine, making a teleport heavy game design or something, but a 32 kilometer by 32 kilometer map is huge. Who knows? The plan right now is to make some kind of multiplayer game with that, because then one of the things that would be nice to do with this engine would be to show that you can make a client server game where the server is running a large number of people, like 500, without it being too taxing for an average person to run. For that to be viable, 32 500 people is way too many for a battle royale, because only one person gets to win every match of a battle royale, and it's bad enough that you only have 1% chance of winning. It would be even worse to go down to 1 in 500 chance of winning. I could change. Like, I'm a technologist, and so I'm far more likely to actually do the technology here than to actually ship a game, right? Like, that's to keep, again, manage expectations. But if I don't ship a game with it, I could open source it and other people could try to use it. Yeah, your spaceship battle idea is correct, but of course you don't do spaceships over outdoor terrain with trees. Like there's not a lot of terrain in space. Is there an order that you will go through for the tech? That's a good question. It is not the order that this is shown in. Most of these items are, the sub items are kind of in order of the likely, there's dependency chains between them. So they're kind of locally in order. But for example, if I got terrain geometry working and I didn't have shading working, you wouldn't really be able to see that much. Like, I could put a checkerboard texture on it. But so I would probably try to get shading going pretty quickly after just getting the very first, like, to get the first item of terrain geometry done, then get shading done, right? So there's one of the things. Why is this no, it's not covered. Okay. One of the things as a graphics developer is that I find it's very satisfying to do graphics development because you get immediate feedback on screen of what you're doing. That's why I kind of love it. Yeah, Terra Nova 2. Wow. Yeah, Terra Nova 2 with 512 people. Like, hey, let me go pitch this game, actually. Which because I said it was kind of inspired by DayZ. Oh, right, because I put it in release mode. Gotta put it back to debug. Slow startup because it's debug. But yeah, so even this would not. Well, yeah, it's not gonna speed up from like, right. We're already at 4 milliseconds per frame, so it's not like we're dying for frames here. This is just generating. You can see rendered 213 vertex buffers. So there's 213 draw calls plus drawing the characters. It's just the CPU does not have much work to do except when it has to rebuild a thing. So let me pitch what this game idea was. So the idea I had was have this giant infinite city and then have it overrun by zombies. I mean, what a cliche, right? But and then it would be a persistent server, yeah, because it's a big open world. So a little inspired by DayZ, you would, come in and have missions to, like, take back the power station and restore power or whatever. But there's no humans living here anyway. It's like you're just this gradual process of trying to recover control of the thing. A little bit like Helldivers 2 they abstract it. They just have an abstract thing and you increment the percentages or something. And I didn't conceptualize it in that level of detail of how exactly that kind of stuff would work, but that's sort of the same idea, right? You would be taking back stuff, and it would be player versus enemy, and you would have teams, but it would be, you could join in at any time. So there's like a squad of 30 guys running around trying to solve a mission, and you drop in somewhere behind the lines and have to catch up to them. I've never played Project Zomboid or seen it streamed, so I don't know what it's like. And I had a bunch of ideas for that. Like maybe one thing is that, like, if you get a weapon upgrade, everyone on the team gets the weapon upgrade, so that, like, you can make that feel more cooperative, right? Like that you team up to get the upgrade, not you like, I want the upgrade and you don't get it, kind of thing. But I don't think I thought about it in a lot more detail than that. I was definitely focused on trying to do the procedural generation because that was the interesting, challenging problem. But so there is stuff like, but it was totally DayZ inspired, but it wouldn't be a looter looter shooter. No, I guess looter shooters are, yeah. Is looter shooter what you call the Battle Royale games, or is that what you call DayZ? Or is it just something else? Is it like a Diablo or something? Um, Borderlands, which I've also never played, so I don't really know. Uh, Control Z. For now, the target will be the 980 Ti. But if I can do it, it'll be, it'll be 120 frames on the 980 Ti so that it could still run on older hardware, right? Like, I will just see where it is. But yeah, if I'm pushing on the boundaries of what the performance allows, then 980 Ti would probably be the target. If I can't, and if I can't get there, I'll, 30 frames per second on the 980 Ti. So there's no hard rule of what the target is. The target ends up being determined by what it turns out things run at. However, I expect this all to be pretty straightforward and fast. So probably vegetation is going to be the limit. And so then you just choose your vegetation density. You have to be consistent if you're doing like a PUBG or DayZ kind of game, because it needs to be fair for the players. So it has to be consistent on all machines. But you pick a vegetation. Mesh task shaders. Yeah, I mean, I thought about that. So one of the things when I was playing with the STP voxel render uses a pretty compact format, but I was thinking about even more compact formats for blocks. And basically it ends up boiling down to, because you can allow blocks, like in Minecraft, you have a block that's like a ladder, or do you have a, no, the ladder's on the side. You have a fence. So it's got more polygons in it. And so I was thinking about like one thing you can do is you can basically say what you can store in your vertex buffer is, there's a voxel here and I want you to draw this face. And that's all you need to store. You don't store any per vertex data at all. You reconstruct that. You basically have a table that says, here are where all the vertices are. But then you get some blocks that are, and so then the way that would work is you'd like feed in an index buffer or whatever, that you're ignoring the indices. The indices all point to that, or the indices tell you you're 0, 1, 2, 3 around the quad, so that you know which entry to load out of the table. But then I was thinking about doing the same kind of thing for instance stuff, where you want to have outdoors, you want to have lots of junk around. And it's kind of instanced across the map, it's instanced, but maybe you don't want to have a lot of instances in one scene. And so what you end up with is a lot of draws, but they're all different buffers. And you could pack them all into one buffer. And I was coming up with weird strategies where you encode basically like 16 bits per vertex, and that's just barely enough to allow you to do this weird pseudo instantiation of arbitrary vertex buffers. But then it turns out, right, there's draw multi indirect that allows you to just draw a bunch of models with a different topology. And I haven't tested whether that's fast enough. But basically, if you just use something like that, you should just be able to do a bunch of instances of stuff. And that's what this will do for buildings and, the human-made, anything other than vegetation. Vegetation will require technology, but drawing basic models won't. So the mesh task shader is the only place where that would be interesting. And I think trees you can just instance, although I do want to do the continuous LD, so it's a little more complicated. But I think vegetation would be the only place where that makes sense, and I think I just won't do it. Is there a cross-platform or cross-vendor OpenGL extension for mesh shaders? Probably not, right? So I probably don't have that option on GL. Like they might have done like the NVIDIA only one. Oh, OpenGL mesh shader extension. I think we just got them. OpenGL mesh shader extension is merged. What does that mean? In what? OpenGL, just a quick post. Here we go. I'll cut and paste it here. That's from 3 months ago. So I guess I could look at it. Is that going to be supported on old hardware? Who knows? Because if it's not supported in old hardware, it's not worth it. Because, right, the goal is to get the performance for... All right, let's distinguish. Let's say a min-spec machine is like... There's like hard min-spec and soft min-spec or something. But so let's say min-spec is like you could play it, but not necessarily optimal experience. Like maybe it's only 30 frames per second. And then the min-spec, not min-spec, but the real spec is going to be something where you guarantee that you get 60 frames per second, and it, you may have to run at a lower res, but like it's reasonable. And if that hardware doesn't support the mesh shaders, then you try to hit the min spec on that machine. Any GPU that's newer is going to be so much faster already. It's going to let you scale out the resolution. Mesh shaders aren't going to help with resolution. It's only going to help with geometry. So you're already reaching the geometry on the old hardware. It's just not going to help on the new hardware. Now, on the other hand, if they do support old hardware, because the mesh shader stuff, the model for how that works does match how the GPUs work internally, probably. But it's just whether they're willing to do the work. Yeah, absolutely. Post links. Let's take a look. What was this relevant about? Oh, okay. Different hardware. It says NVIDIA is only supporting Turing. They just dropped support for Maxwell, Pascal, and Volta. So which one is Turing? Oh, there's a section on mesh shaders. GTX 16XX cards do support mesh shaders. What the heck is a 16XX? Oh, is that AMD? Is that why I don't recognize that? A good example is Alan Wake 2 running on 1080 Ti. Yeah, okay. If you have a lot of... This is exactly it. If you have a lot of complex geometry to make mesh shaders worth it, and you don't have this optimization on our older hardware, you are unlikely to receive level of performance on non-mesh shader capable hardware. Good example of this is Alan Wake 2 running on 1080 Ti. For that reason, I would argue that you should not spend resources on fallback and going for the second option instead. So what he's saying is either you require mesh shaders and don't support previous because it just ain't going to be fast enough, or you don't use mesh shaders. So yeah, I believe what's happening here is that, yeah, I'm just not going to push that much geometry. Everything's going to be continuous levels of detail. So yeah, that's the thing I didn't quite say last time, which is like, I hate popping. I want everything 100% to be continuous level of detail where you never see a pop. That's the plan. Can I achieve that? Who knows? You have to basically, to implement that, you have to always be able to morph between adjacent levels of detail. I think the one exception I'm going to have for that is if you saw the octahedral imposters from Fortnite a few years back for Fortnite trees. I might do trees that way. But the problem is if you do trees that way, people can't hide in the trees because it doesn't have real depth. You can store... in Fortnite, they do use pixel depth offset. But if you have very sparse trees... because they have very solid trees. If you have very sparse trees that you can kind of look through, that's not going to work. So my expectation is that I would only do... Oh yeah, you did ask that question earlier, right? I'll let me finish this thought and I'll come back to it. If you didn't ask this question before, then tell me what the earlier question that I didn't answer was. So what I'm thinking I might try is that once you get to the player draw distance goes away, so now you can't have players hiding trees. Now we can switch to octahedral imposters. And if I want to do that in a continuous way, I was thinking that's probably far enough away that what I could actually do is render the scene, a small cutout window of the scene with just the tree, and the ground, just the ground right beneath it. There won't be any other objects around, and crossfade and basically draw both the trees both ways, the imposter way and the regular way, and as you transition between the two versions, just actually blend between those two drawn things, and then they have to alpha test or alpha to coverage. I'd probably MSAA and alpha to coverage. I don't know if that would be good enough for the transition to look smooth. I think you might need to actually alpha blend between them because alpha to coverage just only gives you 5 levels if you're doing 4x MSA. So I'm not sure if I could get that perfect or if I just can't use the imposter the same way. What is the most complex part of the tech stack? Well, let's look at what we got here. I mean, the shaders will be pretty big, but complex? Yeah, I mean, how are we measuring complexity? Like the amount of code to support it? Because what if the code is simple? Certainly, the most researchy is the vegetation. I don't really know how that's going to work, which also therefore means that I can't say how complex it is. Um, but I'm still waiting for a reply. How do you debug shaders on your old machine? How do you debug shaders on any machine? Oh, do people use RenderDoc, you mean, or whatever? Um, so yeah, you can't really break and you can't really printf debug, although people have done various things for that. But usually it's basically just you include like a toggle, um, like you put a keyboard key that toggles a boolean that's passed into the shader, and then you bracket parts of the shader on that toggle and see what is working and what's not working. And then also you route, you if you aren't sure what's going on, you pick some variable that you don't understand what it's doing and you send that to the output so that you actually see a color that tells you what's going on there. Yeah, staring at a black screen, that's a totally different problem. That's not even necessarily debugging shaders, right? That's the, yes, you can see black screen jokes on my thing. So Shylock, you never answered my question of what do you really mean by complex? Oh, you did. No clue you would know more about this than I ever will ever know. So what I would say is like the vegetation is a research thing because I've never done it before, and of course an art problem. All of these have art problems. For program art looks terrible. The largest single component here is probably the editor for the terrain because I want to do it not with fractals. I want to do it by taking real world data, which is DMs, and cut and pasting little pieces of them together. um, and that's going to be the most work because it's a full editor of kind of stuff I've never done before. Not a priority though. I can just use a single DEM, which is a 10K by 10K map, as a starting point. But that's this entire section here. The terrain texture is certainly complicated, but it's all stuff I've done before or know how to do. Oh, somebody asked what the 4-way texture material thing was way back, and that is just having a big map of terrain, different parts of the world have different ground textures. And so you do that by making a big grid and saying what texture is on each grid vertex and interpolating within. So within a single grid, you have to do the four corners, so up to four different textures, and interpolate them into the blend them together in that region. In physics, I don't know how hard it's going to be to make that fast. If you have to have 500 players and 1,500 zombies, or whatever, I don't know what the ratio is. Oh, sorry, yeah, DEM. I talked about this last time. It's a digital elevation map. It's just a height field, but it's a height field in the geography industry. I don't know what they call them. The map industry. What is that called? There's a let's see if I have it open. Yeah, I do. This is the national map, which is the United States USGS US Geological Survey map, and you can go in here and you say, I want you to give me the I want you to show me 1 meter DEMs that are, and I only want, I guess I can take breaks. And then I say, I want, I want all the DMs that overlap this. And I say search. And each of these squares that are being highlighted on the map are 10,000 by 10,000 meters with 10,000 by 10,000 data points. Cartography. That's kind of it, but USGS is, I don't think, would they call themselves cartographers? Maybe, I don't know. I have a whole bunch of these downloaded. And so the idea is that you just take one of these downloads and like say, oh, I want this river. I'm gonna, you know, have a soft, make a brush out of this river and stamp it down somewhere, and give you more realism than fractals and stuff. Yeah, don't worry about unrelated comments. That happens. The important thing to remember, if we start having a lot of them, is to do this. But it's fine right now. You don't have to do it because we're just chatting. Geology? Yeah, I mean, maybe it is just called GIS. What is the industry? I'm sorry for using AI, but it's going to be the fastest way that uses GIS. What is the industry that makes GIS? The GIS industry, yeah. I mean, who knows if the AI is correct, but I mean, they're a federal agency, so maybe they're not considered in any industry. Yeah, that doesn't. Yeah, they don't consider federal stuff as part of it. Geographic information systems, yeah. Yeah, it shouldn't be. I mean, it is called the Geological Survey, but I think it's geography, not geology. No, don't worry about it. Like, yeah, go ahead and ask your questions. Nobody else is asking any questions, or if you have, I'm sorry I missed them, and ask them again. But yeah, they're not contours. You can see them over here. They're actual height fields. They are just simple height fields, but they are height fields not from fractals or simple algorithms or you don't have to run an erosion simulation on it. It's already been eroded. So yeah, and I have a ton of these downloaded already. The thing is, what I'd really like to do is have correlated color data. Not that I would use the colors directly, but in the editor, if I have color data from the real world, then I know, oh, is this an area is this a river? Is this uh, grassland? Is this farmland? Whatever. And then when I texture it, I can use that as guidance. But the DEMs just have heights, and they have a separate thing. And unfortunately, this really pisses me off. I collected a bunch of this data in 2017, early 2017. And it turns out in 2017, they took out of this system, which is called the National Map, as we saw at the very beginning. This system used to also have color data, but they took it out. And now you have to go use a separate, different API, a different user interface, different way of downloading the data. But even when it was from this system, they didn't line up. They're just totally disparate sets of data. And so you have to then back correlate. And all the data is internally tagged with latitude and longitude, so you can do it. But I never felt like tackling that, because I always just took the DEM and stripped all the metadata out and just reduced it down to a 10K by 10K height field. But now I've lost the latitude and longitude and don't know how to recover the color data. But yeah, so now I can't, if I try to download new data, it's a real pain in the ass to also get the color data for it. What was my favorite problem to solve it working at RAD? Yeah, that was might have been the question I was thinking of. I think making the audio codec that I finished at Epic. I worked on the audio codec. We wanted to make a Bink 3, and we needed a new audio codec for it. So I worked on that for a while, but then I got flipped on to the C compiler or the Oodle. I don't remember what order that stuff happened in. But then while I was working at Epic, they wanted to put Fortnite. They were using ADPCM or something like that for Fortnite, and they really wanted to put it onto MP3 or OGG or something. And so we finished up that audio codec. I think they went on to OGG, but then they went on to my codec, which is, I'm not breaking NDA because it's in like the Unreal Engine. If you look at the Unreal Engine, if you search for RAD audio, you'll get an Unreal Engine release notes that mentions RAD audio. So, and that audio codec was its own new format. It's very much classical in the same style as OGG Vorbis. But it's much faster than much faster than Opus, which is now the standard. But it only gets about Vorbis quality for bitrate, but it's much faster. Like, it's all SIMD'd and designed to be SIMD friendly and stuff. I did not work with C++. So what happened is at Epic, we became RAD Game Tools became Epic Game Tools, and we continued working on our project. Some of us continued working on our own projects in our own setups with our own build system still. So we didn't have to deal with the complexity of the Unreal Engine. The Unreal is all C++, but my code base was still all C. Is that the most complex technical problem? Again, complex is such a weird word, right? Let me push that for a second. Do I keep up with new graphics techniques? Yeah, I try to. Not with too many papers, because he's gone a little too AI, deep in the AI for me. But I follow a bunch of graphics coders on social media, on Mastodon and Blue Sky, and so I usually hear about new techniques through that or through Genric Ilner. What's his last name? I forget. His weekly summary of stuff. What does your development environment look like on a more contemporary PC? What does that mean? Like, are you saying if I ran this IDE on a new PC, what would it look like? Like, what do you mean look like? I'm sorry for like I'm sure that meant something very clear to you. I'm just we're probably operating Ilner. It is. Oh, what did I say? Gendrick Ilner. Um, what was the thing I pushed? Oh, complex technical problem. Yeah, the complex is just too much for me. So is this what you used while working at Rad? I guess. This machine is actually what I used working at Epic when I was at work for home. No, that's not true. I didn't use this machine. I had a Rad machine, and I used the Rad machine. Um, did I use this machine? No, I used the Rad machine. Um, I mean, what tools would you use for development? I would still just use a VC6 IDE. Like, why would I not use the VC6? Why does being on a more contemporary PC matter? I mean, this is an older CPU and an older OS, and I'm not sure which things you mean to change when you say a more contemporary PC. Uh, um, like if I had my druthers, what would I do? What I'm exactly doing, right? Like I'm an independent person. Given new GPUs, you would need new OS install. I don't think VC6 even works now. I Most people don't have VC6 working on Win 7. I have not gotten it working on Win 10, 11, but I have not tried very hard, and it might work. I could also try VC6 Ultimate and see if they got that working. I had to use a newer Visual Studio for the Epic stuff. Um, like I explained last time, a long time ago, like I used to use VI, the predecessor to Vim, and I just found that the debugging experience, the workflow of using the built-in editor in an IDE combined with the built-in compiler and the built-in debugger was a better experience than trying to work outside with a separate editor. And then the IDE or Make or whatever. Like I just felt like that worked better, and so I just committed to learning to use the built-in editor in the IDE, and I've continued to do that. And every time Windows Studio upgrades and changes the UI, I'm annoyed, which is why I stick with VC6 because it doesn't change the UI on me. But I did use, I don't know, one of them, 2015, 2018 for Epic stuff or Rad stuff and Epic stuff, some Rad stuff and Epic stuff. When I was working on Oodle, I had to use that because Oodle didn't support VC6. So sorry, Shylock, I've still never answered your question, but it's just because you used the word complex, which I hate. So ask me that question a different way without using the word complex. What did I say? Oh, VC works fine on Windows. Yeah. No, I imagine VC6 Ultimate works. Like, it's on our tasks list. I've never gotten around to it, but I obviously should. Because, like I said last time, I'm like the ideal person for it, most likely. Although it would mean that I would like stop being pre C99, right? Like I get used to the new compilers and be like, I'm gonna stop. FCB libraries aren't gonna support pre C99 anymore because I don't need to. Because that's the only reason I do it, right? I don't even know if you need new. So I think I started to say this. I don't know on Win 7 how new of a GPU could I use. I don't actually know how far it would go. I haven't tried dropping one in. I have a 1080. I might have a 2080. I definitely have a 3090. I definitely have like four 4090s, and I have one 5090. So I can test on all those things, but it's just not worth targeting those for. I have some of them as a render farm. If you're wondering why I have so many, uh, On the 5090, I was like, gave myself a birthday present, basically, or something. Um, no, I'm not asking for you to explain complex. I'm asking for you to re-ask the original question without using the word complex. Because I've already forgotten what the question was now. Yeah, I wouldn't be surprised if the very newest don't, but I could go to like 3090. That seems plausible. But I'm very comfortable with the idea of uh, keeping targeting of working with the min spec that I'm targeting. For the editor, especially this DEM editor where I want to have lots of these big DEMs loaded, I might run that on the stream machine or set up a third machine that's a Win 11 machine with a 4090, because the 4090 has 24 gigabytes, right? Because the whole thing was I'm going to pack the whole thing into 2 gigabytes of memory, but a 10K by 10K DEM is 100 million uh, elevations. So it's 100 million times 4 bytes. So 400 bytes, but I said I want to store color with each one. So it's 800 bytes for a single DEM. So 2 gig. So on like a 6 gigabyte card, I don't know what is the gigabytes on this 980 Ti. Um, Oops, that didn't go through very well. Yeah, I'm ignoring you. 6 gigs. Okay. Um, so yeah, I won't be able to do very much editing on that. So I might use the stream machine or set up another machine and that I can stream from for that for working with the editor. But when I'm developing the editor, I'll just use target a smaller size and only load part of the DEMs to get it working. It's not annoying. Don't worry. Um, Probably the audio codec was the thing that took the most research. Um, I mean, although it was really a lot more experimentation than research. I read a few papers and didn't find anything useful from, or any time I tried something from a paper, it didn't work. And so in the end, I just experimented a lot. Um, so Iggy, the Flash player, that involved a lot of book research and experimentation on the Flash because when I started the Flash runtime wasn't very well documented. Like they had their documentation, but a lot of stuff about the exact way that the event flow and how all the different elements of Flash interoperated was not clearly defined. A few years later, other people had started to document it better, but at the time, so I had to read all of that stuff, and I had to experiment a lot. But research, like in the sense of experiment, or research in the sense of reading, I guess those are two different things. Have you been experimenting with software renders in recent years? No, not at all. Absolutely not. I did my time in the software renderer well. It was great fun, especially when you only targeted the Pentium. But I have no desire to go back to writing clipping code myself. Yeah, research in terms of reading. Probably the audio codec is the only one that I really, well, unless you count reading a spec, uh, audio codec was the only one that I did much research on. And like I said, none of the research helped. So it didn't actually matter. Again, if anyone asked a question and I missed it, let me know. because we're wrapping up now. Whoops, sorry. Didn't actually care about that. Just having the mouse over. It's a little weird about having this up. You can see what I'm doing. I mean, I could like post it as a gist, and so then you can cut and paste from it or use it as reference. I guess I could put it on my website. Let's put it on my website. What is this to do? SDB platform.h remote. Yeah, I showed that off yesterday or Monday. That it's all except for two functions to bootstrap it. Everything is get proc addressed from a DLL. But you can see the details. I believe I am using WinMain, I think. Pear posted some of the platform layer thing, at least the fiber thing, on my stream on Monday, but he might not have posted his full platform layer. I just have to remember to link that on the website or something. Yeah, that's actually good advice. I think actually, if you make anything substantial, you should actually be able to even transfer that code to a different framework. It may be annoying work, like maybe there's busy work if you're interacting with it heavily, but like I think I did port something from SDL to SDB platform. In fact, I don't remember for sure though. I mean, I could be wrong. Maybe there's some cases where the frameworks are so different that it's difficult to get between them, but that's a beefy file. That is what happens when you make single file header files that have to do a lot. How big is that? Oh, it's only 6,000 lines. SDB.h got up to 20,000 lines at one point, although I stripped it down. It's now only 13,000. So it's half of SDB.h, so I don't feel bad about it. I think SDB image is 4,000 lines, maybe? Let's see. No, SDB.h is up to 8,000 lines. So SDB platform is smaller than SDB.h. So there you go. I don't, well, maybe the Laplacian texture stuff from the last stream. I don't retain thoughts from papers very often. Like it's hard for me to name any papers at all, much less name favorite papers. Like I have a directory with a whole bunch of papers, but I couldn't tell you what's in it. No silver bullet. No silver bullet's always good. Yeah, see, am I off center when I'm? Yeah, I am off center. Oh, that's just because this camera fell over and I didn't put it in the right spot, probably. It should be here because I have a marker for it. Is that better or worse? That is better. Okay. So yeah, so I'm sorry for the non-answer, but it's just legitimately I could go browse the papers I've downloaded, but I'm not sure I would necessarily have the ones that I care about, and plus a lot of them have terrible names, so I can't tell what they are offhand. Um, I mean, I guess I can just put this on the screen. Uh, Fabian had a good paper, maybe one of the ones, maybe it's in the list that he recommends on his blog. The paper about the system for self-perturbing the file to see how environmental factors change performance, like that showed that like a lot of optimizations are questionable because they're just happen to be putting the code in different orders or different places that happens to interact with the caches or something. Um, I understand your question in terms of what you mean by over-indexing and the kind of the category of things you mean, but I don't know what you mean by in that area, and I don't know by what you mean by from city people. Maybe I don't follow the right people, so I'm not sure who this is that's doing this. Like you said, maybe it's him and here people, so that's one class of people that you're potentially talking about. But I don't follow their posts even that much. So like I don't follow Casey on social media. So like big oops. I know he's done these uh, various YouTube podcasts, but I don't know if he talks about that kind of stuff. So maybe you're talking about different handmade hero people too. I was interpreting over indexing as being over emphasis, basically. Not actual indirection. Yeah, I don't know what Casey or Ryan. I don't read Ryan's stuff. Do you have any idea how to design a good API? Um, I don't know that I can educate it. Casey had tried to do education on it. Right, a lot of it is experience. Like the classic trick is write the code that uses the API so that you can make sure that that makes sense. And that's a good trick. I don't do it that often anymore because I've kind of internalized what I need to know. But I mean, and I may still do it. If I can't picture what I need clearly enough, then that's a good way to help picture it. Um, but yeah, there's just lots of things of like, you know, with object orientation, people spent a lot of time talking about like, well, how do you construct your hierarchy and kind of trying to communicate these ideas of where boundaries need to be and stuff. And so there are similar things like that for API design, and nobody's really talked very formally about it. And so I don't know, I don't have a vocabulary for it. Like one thing I'll say about programming is the classic idea is top-down design, where you say, I want to, accomplish this, and the way I'm going to accomplish this is by breaking it down to these 3 subtasks, and then for each subtask, I'm going to break it down into these things. And I historically have done a lot of bottom up programming where it's like, well, I know this thing needs to get done, so I'm going to write the code to do that. And that just means you already understand the problem is the thing, right? Like, I think the top down is meant for when you don't already understand the problem. With bottom up, you could easily end up with stuff you don't use, right? Because you could write something thinking you need it, and then once you finally do you reach the top levels, you're like, oh, I don't need that after all, or it needs to work differently than I thought, or whatever. But yeah, I mean, I'm hypothesizing here. I still think I work mostly bottom up. And so if you're working bottom up on the code that uses the API, then you have to write a lot of code, I guess. Do you have any idea for general purpose game engine? Like, if you were to write one, no, I don't have any idea. Like, it's a really weird problem of like that, your engine ends up too FPS oriented, or the Order of the Sinking Star engine is going to be very block pushing oriented or something, so pseudo isometric 3D or something. C is gravity direction. I don't know what that was in reply to, but I agree. I know you're probably quoting me, but Charlotte, I'll come back to that as I want to answer this other question first because your question is more in depth. And if I forget, remind me. Um, so the GPU font renderer, yeah. So it works by not SDF, but by directly uh, intersection test, however you call that, against the font outlines. Um, so in the shader, it gathered enough of the adjacent edges, curved edges of the character to be able to figure out is this point inside or outside the character. It was based on Will Dobby, I think. He had a pretty good thing. But when we tried to productize it, we found that it was a lot more subtle than what he had done. There were glitches in his approach. So we spent a lot of time trying to figure out to make it glitch free, and we did. But I was like, a full screen of text, of small text, on my whatever slower, 680 that I was running or whatever, was about 4 milliseconds to render. And it just felt like that's way too much time to be spending on like UI. Drawing a screen of text should not be 4 milliseconds. And it would be worse maybe on mobile. So we're just like, yeah, it's too slow. It's not worth it. Now, it might be now, but at the time, it seemed too slow. Um, the what's his name did do a font renderer um, that has a name because he licenses it, and I can't remember what it's called. That uses a similar kind of algorithm. Yeah, Slug by Eric Lingle. Lingle, yeah. Um, and he also solved some other problems in there besides just the rendering, but the rendering is the big one. And then he sought patents on it, I think. So I'm just pissed off about that because we were doing a kind of similar algorithm, and you know it may or may not be covered by his patent. So fuck him. Like I'm so like patents used to be this big thing what we worried about 20 years ago because they shouldn't apply to software, and they're supposed to not apply to obvious stuff, and yet they're constantly patenting obvious stuff, and your only way to threaten a patent is to show prior art. To get a patent reversed is to show prior art. You can't show that it's obvious. So there's just this totally broken system. And then there was a court that kind of said basically, this doesn't seem correct, and reversed the patent. And it felt like, oh, maybe we do have a way back from the patent thing. But then everyone just stopped talking about them entirely. And I was like, okay, I guess nobody's patenting things anymore. So, well, but they do patent things. So I'll give you an example. Opus has a bunch of things in it, and it's open source, patent free, because the patents that they used, the people who own the patents gave a license that you can use it for free in Opus. But it means when I made my audio codec, I can't use the techniques that are in Opus that are patented because I don't get that license because it only applies if you're in Opus. Bullshit. And of course, they've like documented how Opus works and all of the clever things that they've done. And it's like, thanks for documenting this stuff that I can't use because some of it's probably patented. It also turns out Opus, there is contention. There are people who say some of your stuff that you're doing in there is covered by our patents, but they've never sued, and so it's just whatever. TTF had a patent on the hinting subsystem, which is the VM. Yeah, that has expired since then. And we did not have hinting in STB TrueType, and somebody was talking about adding it, and I don't remember whatever came of it. Maybe there's a pull request that adds it, and I've forgotten about. But yeah, so yeah, it was nice that we just got kind of mostly stopped worrying about patents, except in these extreme fields like audio and video codecs. Um, I never wrote up what's in Rad Audio, and I never will, because maybe somebody out there has a patent on something I'm doing in it. I don't know. And if I publish a white paper saying this is what we do, that's just going to say to those people, hey, if those people find that paper and read it and go, oh, they're doing the thing we've patented, let's sue them. So there's no, like, that risk is too high. The risk that I'm unknowingly violating a patent is too high for me to publish what I'm doing. It's so dumb. Like, it's just all antithetical to advancing science, to the extent that you can call programming science. Um, what was the question that you asked, Charlotte, that I said, let's come back to it? Oh, STB image preference. So, um, there's a misdesign in the Huffman decoder, but Huffman decoder, there's just one, it's a very well-known classic Huffman optimization thing. Um, so, can you see the bottom of the whiteboard? Yeah, you can. Maybe I can just pivot it rather than lifting up the monitor. Yeah. So a Huffman code is, you have symbols that are differentiable when you decode them. You would. This is not in canonical ordering, but whatever. I don't want to keep going. So that's a set of Huffman. Oh, I gotta remember to switch to the thing so you can actually see that. Hang on. Scene 2. There we go. So you have these Huffman codes. And the idea is that if you read one bit at a time, you'll know when you hit the end of the symbol because they're unique. They're called prefix codes. They have unique prefixes. So yeah, the Shadow of Mordor patent, it was just so dumb to do. Like, nobody, it would have been great if other people had explored ideas and variations on it, and they just guaranteed nobody would, and it wouldn't have mattered in terms of sales. Nobody was going to sell more just because they decided to try doing Shadow of Mordor. It would have been based on the quality of how well they did it. Anyway, so you can read a bit at a time. You read a bit, and it's like a 0 or 1, and then you read another bit, and if you read 2 zeros or 2 ones, now you know you're at the end of the thing, and you can stop. So you have this bit stream. And I'm secretly showing you how it decodes. And what you do is you read, instead of reading 1 bit at a time, you read, say, 8 bits at a time. So you read 0110011, and then you look up in a table. And in that table, every single thing, that starts, every single, so 0110000, 0110001, 011, everything that starts with 011, all of them have a pointer to, or have the value C. They all say, oh, you just decoded a C. So now you've read 8 bits, but you haven't consumed any. And now you look and you say C is 3 bits, consume 3 bits out of the bit stream. That's the main trick of fast Huffman. Then there's lots and lots of detail about how to do that. How to code the bit stream, how to decode from the bit stream efficiently, because you need to keep shifting over the bits. It's a var bits problem. That's what we call it at RAD. You need to keep a bit buffer that's not aligned with the bytes, and that you're going to use to look up what's the what's the next token. Did that make sense? Yeah, at just every possible value, right? Like, if it's an 8-bit look ahead, you have a 256 entry table, and you just store. If the symbol is no more than 8 bits, you just store what symbol it should decode as. There's more complicated variations. I mean, maybe store what symbol it decodes as and the number of bits, so that you don't have to go indirectly look up. So the bug in STB, or the mistake in STB image, is that if the actual Huffman code is longer than the look ahead, then you now need to go like a bit at a time and find the real symbol. And I actually do this weird binary search, at least on one of them, instead of bit at a time, because I thought that would be faster to binary search. There's a sweet spot, which is based on the cache size that the table uses. So like, I better check before I say it. Why am I so bright again? The rig blog. Where would I find? Oh, if I go. Huffman, that, and then I go rig. Public blog. What can I search for to find? Oh, here we go. All right. No, it's this one. So if you scroll down to where it says Huffman coding in OODLE, our older codecs, namely OODLE LZH and LZHW, used a 15-bit code length limit and multi-level tables, both common choices. So multi-level tables meaning you decode n bits, and then if you haven't found it yet, now you have another table for the remaining bits. The problem with this design is every symbol decode needs to check whether a single table lookup is necessary, and there's bit IO stuff. So where they ended up with is if codes are limited to at most 12 bits, the 32-bit decoder can, etc. And as a side effect, the tables with a 12-bit code limit are small enough that fits in the cache. If the codes are limited to 11 bits, you get some other benefits on the bit decoder. Therefore, the new OODLE codecs use Huffman codes length limited to only 11 bits. So you just grab 11 bits and look in the table and you're done. It always has a symbol in there. And that's part of like the Kraken compressor and the other OODLE compressors that are considered the fastest, among the fastest Huffman decoders around. So that is what they came up with as the strategy for that. Does he talk about what the table actually looks like? Because I don't want to spill any proprietary data. No, he doesn't talk. They don't talk about what the table looks like. Well, he kind of does in the pseudocode. He implies it. In the pseudocode or the code, it's not even pseudocode. In the code, you can see that they look in this table. If you search for decode first symbol, see if yeah, okay, that's the first one. Oh, it's right above that struct huff table entry. uint 8t len uint 8t sim. So the length of the code in bits and the symbol value. So each table entry is 16 bits, 2 bytes. There's 2 to the 11 of them, so the size is 2 to the 12 or 4K. So 4K is going to fit really well in your L1 cache, and so you're going to be reading out this table very efficiently. So that's like the really hardcore end of the fast Huffman. STB image doesn't do any of that stuff. All it does is that lookup table. The codes aren't guaranteed to be the length limit, so it's not necessarily that fast. In fact, I think the STB image Huffman, STB image PNG coder people have complained is a little slow, but okay, did I miss anything while we were talking about that? But yeah, so no cyan, that's the sweet spot issue, is that yeah, you need to, what you prefer to fit in cache. But yeah, and there's a lot of subtlety that Huffman stuff. You can encode the bits in the opposite direction. Like there's all sorts of things, but that's the high concept. And then the rig blog gives you the really hardcore version of it. And yes, reading bits in way too many ways is also relevant to this. That's how do you get the bit buffer to work? And there are lots of ways to do it. And they tried lots of them and found whatever they found was optimal for. Well, originally it was for the Jaguar, the AMD CPU that was in both the PlayStation and the Xbox, whichever one that was, Xbox 360 and PlayStation 3 or something. Whichever, I can't remember which ones came out at the same time. Xbox One and PlayStation 4, maybe, because those sound old for Kraken. Too old for Kraken. But anyway, yeah. Okay. Yes, you're welcome. PS3. Oh, PS3 had the cell. What? This, but the PS3 still had a. But yeah, it was like a RISC machine or something. PS3 had the cell as a sort of more of a co-processor, not the main processor. It's just it was you tried to do the heavy lifting on it, but it was a lot more complicated. So most code in terms of quantity of source code, not execution time, but in terms of quantity of source code, still ran on the main CPU. What's the current project? Just got in. So yeah. I brought up this papers to try to see if I could find any papers that were important to me, but I don't. These are just random papers that I read. Nothing stuck with me. Quadric error. This is old. Surface simplification using quadric error messages is a really important paper in generating LODs by decimating meshes, because it talks about a good error metric for doing it, and for like you have texture coordinates or colors that you also want to preserve. So that's an important one. Oh, scene switch. Yes. Thank you for telling me. There I was reading that rig blog and you couldn't see it, although I had linked to it, so it wasn't that bad. But I don't actually even remember the details of the quadric error metric, so it's not like a paper that stuck with me that way. Yeah, this Alex Evans paper about dreams, which was just brains, all the different things that they tried, and it's just a whole bunch of different things that they tried to do before they ended up with the system for dreams. It's a pretty good talk. What's the oldest file in that folder? 1997. Because I wrote a paper about something like that, so I was referencing somebody else to see whether they did. But it's a PS, so I probably can't even open it now. No. Although that would be the date of the paper, like, because I see this triangular. There's no way I downloaded that until I was at RAD 10 years later. So this could be that the papers preserved the date that the paper was rather than the original. Although this one clearly didn't. Okay. So yeah, what am I working on? Pro is 4. So yeah, what am I working on? Let's get back to. Oh, we're in the right one. No, it's technical to do. So I am currently working on. There's nothing to see because I haven't actually even started it, but I've done similar things in the past. An open world terrain renderer and an end game that in the other version of this, you can't see the repeating textures that you can on this, but and these are all the things that I have to do technologically to do it. And the idea is that it is a 32 kilometer by 32 kilometer terrain that's stored entirely in 2 gigabytes of GPU VRAM, so it can run on I intentionally have an old GPU. It's a 6 gigabyte GPU. It can run on that. There's no streaming. You load it into memory and it just runs. You can teleport anywhere on the map instantly. Not that I have a gameplay reason for it. and so it's a solution in search of a problem. But it's just an interesting challenge. I I kind of pitch it as trying to show people what's possible is sort of, I mean, a possibility is that I come up with a game and ship it. Like, it's not like that's not I'm not viewing it like OBBG. I viewed OBBG as make work. Like, this is definitely something I could pursue as a game, but I probably won't. But you know, and who knows? Um, but just knowing me, I probably won't. Much like the I demoed earlier a voxel city, procedural city that, yeah, I never did anything with. But so it's sort of just a proof of, to some extent, it's a proof of concept. Hey, you can make a big outdoor terrain without too much compromise, and it doesn't need a stream because it can fit in 2 gigabytes of memory, which I think is probably surprising to people. In the same way that I was trying to make a C compiler that could maybe compile 10 million lines of C in a second, because more because it would be nice to have, but also kind of to show people that, like, yes, computers are that fast and combining. Like, yeah, I wouldn't be doing everything that LLVM is doing. I wouldn't be doing all the crazy optimizations that they're doing that give you 0.1% more performance. And so then one of the other things that this would potentially demonstrate is that it would be a client server multiplayer game, because a big terrain like that is very much like an Arma, Daisy, PUBG. Bigger, it's bigger, a lot bigger than those actually, and maybe have like 500 players running and have a multiplayer server that's not doesn't have to be very beefy, so you could host it on your home machine. So that's sort of the pitch. No idea that I'll do any of this. That's just what the point of this project is, though, which is what you asked. Which, so it's a totally legitimate answer. I just want to make sure nobody thinks crazy. But yes, thank you for reminding me of the scene switch. My current setup, I don't have the monitors in the right place, so I don't see my. I have to look all the way over here to see the preview on OBS, and I'm never going to look that. I turn my head more than 90 degrees to see it, so I need to have it right here on this monitor, or right here on this monitor, so that I can see it quickly and remember. So thank you for reminding me about that. Yeah, and it is all OpenGL, which is not a particular barrier to being a fast and good, because most of the speed lives inside the shader, and so the shader is going to run the same whether it's OpenGL or Vulkan, and so you're all good. All right. Well, we were at 2 hours and I was basically done, and now we're at 2 hours and 50 minutes. So I think we'll stop. Uh, yeah, you get no max movement speed, which might allow for something interesting, but I don't have any game design stuff for that. Like, you could have a helicopter. That was certainly something I thought about, but um, that was definitely something in the zombie city thing that we showed off. One of the ideas I had is that you'd have these overhead highways, because I didn't want to complicate building the buildings. So for highways like that were big, fast travel, you would have them up higher on the. There's literally nothing to show. I just showed it. Like, I just showed it. It's just I just have a flat terrain, a flat texture. Um, the Oh, well, okay, yeah. There's literally nothing. Um, that's it. I mean, and it is just drawing a big square. Like, it's not doing anything. It's not doing any terrain stuff. Um, it is trying to reduce. It's a bad version because I forked it for the real version. It's doing this thing where it's using different. Let's see. So it's trying to reduce the effect of tiling. Yeah, so you can see in the distance. Let me. I push the match scaling. You can see the texture repeats a lot. So it has some anti-tiling technology that I have a much better version of, but this is how it works. And that's all that's actually in the code base right now. Um, don't apologize for all the questions. I got, especially when I say the stream is ending, or I'm done with my side of things. Then the whole point is to have questions. Oh, and you don't have to apologize for asking. I just didn't know that you hadn't seen it. I had assumed you had seen it. So yeah, no apologies. Okay, so yeah, that's it. No, I mean, as I said last time, the whole point of OBBG was to help communicate the knowledge from the old guard to the new people. So that's definitely still, it's not going to be the priority this time, but it is, especially at the end of the stream, something I'm happy to do. And also, if we end up on the STB maintenance streams, or the otherwise sort of more hangouty Fridays, then those will definitely also be free for ask me a question that requires me to pull out the whiteboard and talk for half an hour. Like, that's going to be fine too. Because remember, I'm not employed now, so if I'm not doing this, I'm watching YouTube videos. So, first approximation. Anyways, thanks for everybody for being here. Still at 144 people. Crazy. All right. See you later. This will be on YouTube, of course. Bye-bye.